This is section 7.2, Inverse Functions and Relations. Our objective today is I can find the inverse of a function. Talking about inverses, we're really just saying that we're going to be switching the x and the y values. So as you can see in the example, we have a point 1, 5, and in the inverse we wrote 5, 1. In the original function we have 2, 6, and then we switched them and got 6, 2. And in the original function we had 3, 7, and then we switched them to get 7, 3 for the inverse. Looking at example 1, we're looking at a geometry example. And the answer is already actually given here for you, but it says that we're looking at our original graph, which in this case is just A, B, C, and we can see that here. And they're wanting to know what the inverse is. So in order to find the inverse of this, we need to know the points. And by looking at the graph, we see that A is at 1, comma, negative 2. B is at 2, comma, 5. And C is at 4, negative 1. So when we go to write the inverse of this, all we're going to be doing is switching those numbers. So here we'd have negative 2, comma, 1 for the inverse, 5, comma, 2 for the inverse, and negative 1, 4 for the inverse. And as you can see, that's exactly what they've stated here. They listed out the original points, and then they found the inverse of the relation just by switching those values. It also said to describe the graph of the inverse. And here, if we go ahead and plot these points, we can see that all of the points are going to be a reflection over the line y equals x. In example 2, we're going to be finding the inverse of the function and graphing the function and its inverse. So what I'm going to go ahead and do, I'm going to go ahead and plot that original graph. And in order to do that, I know that my equation y equals mx plus b, we know that the b is going to be the y-intercept. So in this case, negative 5 is my y-intercept, so I'm going to go ahead and plot that. And then we know that my slope is just going to be 2 over 1, so I'm going to move up 2 over 1, up 2 over 1, up 2 over 1, and so on and so forth. So I can go ahead and draw my line. And now I'm going to actually work on finding that inverse. So if I go ahead and do that, I'm going to first go ahead and rewrite my function with a y. So I'm just going to rewrite because we know that f of x is the same thing as y. So I'm going to say y is equal to 2x minus 5. And then in order to do the inverse, I need to change the value of x and y. So I'm just going to move my x where my y is and move my y to where my x is. And then I'm going to need to get that y by itself. So just like if I'm writing it to get it in slope-intercept form, that's what I need to do here. So if I do that, I'm going to subtract 2y on both sides. So I get negative 2y plus x equals negative 5. I'm going to subtract my x on both sides, so that I have negative 2y equals negative x minus 5. And then I'm going to divide everything by negative 2. So I'm going to end up with y equals 1 over 2x plus 5 over 2. And then my last step is going to be to replace that y with our inverse sign, which is f of negative 1x. That just means the inverse is equal to 1 over 2x plus 5 over 2. So now I need to go ahead and graph that, and I'm actually going to graph this line in red so that we can see the difference. And first I need to find that y-intercept. So 5 over 2 is equal to 2.5. So I'm going to go ahead and go up on my y-intercept and graph that point. And then I need to move up 1 over 2, up 1 over 2, up 1 over 2, and so on and so forth. And I can go ahead and draw my line, which looks like this. And from this you can see that this graph is actually being reflected over y equals x, which I'm going to draw in blue. We're going to do the same thing here. We're going to be writing the inverse and then graphing the two. Now, before I go ahead and find the inverse, I'm going to go ahead and graph. And in order to do this, I'm just going to make a real quick t-chart. I'm going to underline this in red, and I'm going to draw my line in red. So I'm going to have x and y, and I'm going to use -1, 0, and 1, and see if that gives me enough points. -1 squared is going to give me +1. 1 plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. So if I graph this, I have -1, 2, 0, 1, and 1, 2. So I can go ahead and connect these. We know that since it's x squared, it's going to be a parabola. And yours will probably look a little neater than mine. So now let's go ahead and find that inverse. So first, we need to replace the f of x with y. So we have y equals x squared plus 1. Now we're going to switch the x value and the y value. So we have x equals y squared plus 1. We need to go ahead and get that y by itself. So I'm going to go ahead and subtract my y squared on both sides so that I have -y squared plus x equals 1. I'm going to subtract x on both sides so that I have -y squared equals -x plus 1. I'm going to divide by a negative so that the y is positive. So now I'm going to have y squared equals 1x minus 1, and then I'm going to take the square root of both sides. So our final answer here is going to be y equals plus or minus the square root of x minus 1. And again, we're going to be reflecting this graph over y equals x, which I'm going to draw for you in blue. And so we're going to have to draw it reflecting. So if I do that, remember I can use those points that I came up with originally, and I can just work those backwards. So in this case, instead of -1, 2, I'm going to have 2, -1. So I'm actually going to do this in a different color. And so my inverse, f of -1 of x, which I also need to do over here, f -1 of x, for my final answer is plus or minus x minus 1. So on this new chart, we're going to have 2, -1 is my point. So 2, -1 is going to be right here. Then instead of 0, 1, I'm going to have 1, 0. And then instead of 1, 2, I'm going to have 2, 1. So now I have my 3 points, and I can go ahead and draw my parabola. In example 3, we're looking to determine whether each pair of functions are inverse functions, and we're going to explain why. So, in the key concept that you have on your notes, you can see that we can be able to tell if these are inverses by using our key concept. So we know that in order for them to be inverses, we have to have f of g of x equals x, and we also have to have g of f of x equal x. So we have to show this. Looking at example A, we have f of x equals 3x plus 9, and g of x equals 1/3 x minus 3. So let's go ahead and look at f of g of x, and we can go ahead and use this. We know that we can rewrite this as f of g of x. So we're going to have f times 1/3 x minus 3, because we're plugging in g of x. So that means we're going to be plugging in this dude anywhere there was an x for my f of x function. So if I go ahead and do that, I'm going to have 3 times 1/3 x minus 3 plus 9. And if I go ahead and simplify that, I'm going to distribute my 3 through. So I'm going to have 1x minus 9 plus 9. My 9's are going to cancel, so my answer is just going to be 1x, or just x. Now let's go ahead and test the second one. So we have g of f of x, and we know we can rewrite this as g times f of x. So now we need to rewrite this. We know that we're going to be plugging in 3x plus 9 for that f of x. And then we're going to be taking our g of x function, and anywhere there's an x, we'll be plugging in 3x plus 9. So we're going to have 1/3 times 3x plus 9 minus 3. I can go ahead and distribute here so that I have 1x plus 3 minus 3. Here, my 3's will cancel, so I'm going to be left with 1x. So in this case, we can say that they are inverses because these two things are equal. So let's go ahead and take a look at the second example. We're going to do the same thing here. So first, we'll test our first example. And we know that that's going to be written as f of g of x. So we can go ahead and plug this in here. So we're going to have f times 2 square root of x. So then we can go ahead and plug in for our f. So we're going to have 4 times 2 square root x squared. Now if we go ahead and distribute that squared, we're going to have 4 times 4x, which equals 16x. Now, we don't even need to do the second step because as we can see here, this does not equal x. And according to the key concept, it must equal x. So this one, these are not inverses.